All right, since we are focusing on the real GDP, right, rather than disposable income, we are just going to change from the disposable income to the real GDP here. This is a Y instead of YD. And of course, YD and Y, they move together. Okay, now we want to focus on the changes on consumption and saving that is a result of a change in the GDP, the real GDP. Now, there's two different ways of changes. One could be changes along the consumption curve and saving curve. And the other one is a shift, right? The schedule of these line shifts. So now we are going to take a look at what could cause changes along the schedule. Since along the schedule means only these two variables, right? The Y and the C is changed. So since consumption is a function of the output, so consumption will change in the amount of consumed will change, right? Because of the income or the real GDP's change. So changing along the curve, okay, would be when income changes or when real GDP changes, so that the amount of consumption will change. Saving is the same thing. So that means the change in amount of savings, right? So that is the function of the GDP, real GDP. Other things that could shift, okay, right? That could shift the saving, right? Other things that could shift the saving. The question is, how about taxes? Will tax change the consumption? Definitely. Raising taxes up, that will lower the consumption down because disposable income will be lower, right? Increasing in taxes supposedly will drop the saving down as well. Okay, so lower taxes shift both curve up. Okay, let's do it different way. So lower taxes, let me erase this for now so that it would not be so messy. Okay, so if we raise taxes, so at any given real GDP, it's not going to be the same amount of consumption, right? So if we raise tax, but now let's do lower taxes, it will shift the consumption line up. Okay, right? So that means we can consume more, correct? We can consume more. Since taxes affect both spending and saving, right? So saving will be also higher. I need to change the color, right? Because saving start with the red. Now you're going to see saving with a little bit the green one. Okay, both of them. If that is the change in taxes, will shift both curves up since taxations affect both spending and saving and vice versa, right? Economists believe that the consumption and saving schedule are generally stable unless deliberately shifted by government action. So now C and D, C and S, consumption and saving, how does it shift? So if assuming that if households consume more at each level of real GDP, right, that means they're going to save less. If they consume more at any level of GDP, then they're going to consume less. Graphically, this means that the upward shift of the consumption schedule entails a downward shift of the saving schedule. Okay? If households consume less at each level of real GDP, then the other way around, right? The saving will be more, and that would be opposite. But normally, when tax is in the picture, it will be different. Okay, I just show you how the tax affect this. Now I'm going to start over and then talk about what if there's no change in taxes, right? If there's no change in taxes, and all of a sudden, I'm going to use a different color. If all of a sudden the behavior of consumers change, okay, if there's an upward shift from this line to the pink line without changing tax code at all, right? More consumption means less saving. So saving is going to shift this way. And that makes sense? Okay, they're two different things. Now, The first one is about taxes. They kind of move together. But the other one, what if, is about pattern, right? If it's all about pattern of consumption, then the opposite will happen to the saving, right? Consume more, save less. Consume less, save more, just like that. All right. That makes sense? Okay. So if that makes sense, we are going to move on to the next topic, please. So the next topic is about aggregate consumption function. Aggregate consumption function. From what we just did, right? From what we just did, the table on the page 4 that we just did, we found that MPC is 0.75 and MPS is 0.25, correct? So we are going to derive a consumption equation now that I was like writing it down, that C equals A plus B times Y, right? YD in particular. Okay, now I'm going to elaborate this equation. This is called aggregate consumption equation or aggregate consumption function. The consumption function is A plus B, which is the MPC, marginal propensity to consume, and multiplied by the disposable income. What is A? The part A is called autonomous consumption spending. Autonomous consumption spending. What is an autonomous consumption spending? It is a spending that you need to spend regardless of your income. You're going to have to eat, right? If you did not have any income, you still have to spend. Okay, this is regardless of the income. This is the amount that will happen anyway, right? A. On the graph, that's your intercept. Now, the other part is what we call income-induced consumption, income-induced consumption, right? Which, depending on the behavior of the marginal propensity to consume, how much, every extra dollar, how much would that be spent on consumption? So we're assuming that right now, I'm just going to leave tax out for a moment, right? We're assuming tax doesn't really change for the moment. So it's just okay to rewrite the consumption equation this way, okay? And then saving equation will be opposite to this, meaning when you need to have this autonomous consumption spending and you don't have income, that means you're going to have to borrow. So that's why it's a negative A, okay? You have to borrow. And since MPC is how much you consumed, MPS is how much you spend, so that is kind of a mirror of the consumption equation. So now you have two equations, right? I'm going to write it the same way. We just use Y, okay, instead of YD. Oops, I wrote it wrong. MPC times Y. Okay, now you know why we switch from YD, which is Y minus T. T stands for taxes. All right, so now let's take a look. This is exercise 1 that I would do in our discussion, but I will do right here, and then in discussion we can do more of this example anyway. So in this example, you have disposable income and the consumption expenditure. When there's no income at all, you still need to consume 40. Income going from 0 to 100, the change in income is 100. You consume from 40 to 100, you have a consumption of 60. And you can check another point, from 200 to 300, change in income is 100 again, but that change contribute to a change in consumption of 60. So now this table above gives you information about the economy, right? Let's find out what is the MPS and the MPC. Also typo. What's the value of MPS and MPC? I already kind of started for you. MPC is delta C over delta Y. So that MPC then 60 over 100, right? 0.6. If MPC is 0.6, then MPS is 0.4. Then you are going to derive consumption equation and saving equation. Okay, so the consumption equation is A plus MPC times Y. In this case, it's also disposable income. So let's find out what is the A. This is an intercept when you have no income at all. It's straightforward. So the consumption equation then, C equals 40 plus 0.6 times Y. S equals negative 40 plus 0.4 times Y. Okay, I hope you see that easily. So that is an aggregate consumption function and aggregate saving function. So this is going to be the only variable that in our aggregate expenditure model, C plus I plus G plus NX, we are going to assume everything else autonomous except consumption that has two parts, autonomous, and the other part is income induced. Okay, so one part of the consumption is autonomous, another part of consumption induced by the level of income. All right, now let's do further, please. On the next one, in an economy, there's another example. Let's call induced expenditure, right? Income induced. Oh, did I say induced income? Manisha. Let's call income induced expenditure, autonomous expenditure and induced expenditure, just to be precise, right? Income induced expenditure versus autonomous expenditure, just to be complete. All right, income induced expenditure, autonomous expenditure. Again, let's divide it on one more time. Induced expenditure depends on the level of income, right? It depends on income. But autonomous expenditure is independent of income. In this case, the income is the GDP. Okay. All right. Now, let's look at another example here. In an economy without taxes, without import, an increase in investment of $50 billion will increase equilibrium expenditure by 120. What is the value multiplier and the slope of the aggregate expenditure curve? But this is a bit much. We're not there yet, but we will get there later. In this in session, we will do this. Okay, now let's get to another variable, right? There are two variables. We already did consumption and saving. Now we are going to do interest rate and investment. So we learned from chapter 9, interest rate and loanable funds and everything, that in order to look at the investment demand, we're looking at expected return, we're looking at the real interest rate, and then we get the demand curve, right? Investment demand curve. So investment consists of spending on new plants, capital equipment, machinery, inventories, and construction and everything. So the investment decision weighs marginal benefit and marginal cost. So the marginal benefit is right here, expected return, and the interest rate is the marginal cost, right? So the marginal rate of return is the marginal benefit, and the interest rate, which is the cost of borrowing funds, represents the marginal cost. So the expected return, the expected rate of return is found by finding the expected economic profit, right? A total revenue minus total cost as a percentage of the cost of the investment. So we are going to take a look at very simple right here. Now, you can take a look at how to find expected return. We did that in chapter 9, right? So right here, we are going to look at the real interest rate, and we are going to use the term R for the real interest rate, I for the nominal interest rate. I, which is the nominal interest rate corrected for expected inflation, which means I is your real interest rate. Okay, the I is your real interest rate, and the R is the return. Okay, rate of return. R is the rate of return, rates of return. Okay, R is the rate of return, and the I is the real interest rate.